Okay, so in this class, let us discuss about the operations on graphs. Okay, so let me consider two graphs, G1 with a vertex at V1 and edge at E1, and consider another graph G2 with a vertex at V2 and the edge at E2. The union of these two graphs is nothing but the union of V1 V2 as a vertex set and the union of E1 E2 as a edge set. Okay, that is known as union of these two graphs. So let us define some of these two graphs. Okay, so if the vertex set v1 v2, okay, if the vertex set v1 v2 are disjoint, that means there is no common point. In such case, the union of those two graphs, corresponding graphs, is nothing but the sum of the graph and the intersection of two graphs. Okay, so if v1 v2 contains the common vertices, okay, so then the graph G, which is obtained by the intersection of the corresponding v1 v2, so that is your vertex at V of G, and the intersection of E1 E2, that will be the edge set of G, so that is the intersection. Okay, so let me know about the join of two graphs. Okay, suppose G1 G2 be any two vertex disjoint graphs. So I consider G1 G2 where the vertex set is disjoint. So then the join G1 G2 is symbolically represented by this, right? It is what? It is the super graph of G1 plus G2 in which each vertex of G1 is also adjacent to every vertex of G2. See, so for example, look at this example. This is G1 and this is G2, and here I am just calculating the join of these two graphs. Okay, so we need to consider this graph as well as this graph, and we need to consider each vertex in this graph, and that must be adjacent to every vertex of these graphs. So look at this u1, which is adjacent to v1, v2, v4 as well as v3. So like that, so u2 must be adjacent to every vertices. Okay, so that is known as join of these two graphs. So if G1 G2 or any two graphs, okay, like this, so then what is G1 plus G2? So G1 plus G2 is nothing but what? The union of two graphs G1, the union of two graphs G1 and G2 whenever V1 V2 are what? Whenever the corresponding vertex set are disjoint. Okay, and observe here, if let me consider a complete graph K1, okay, and let me consider another graph C6, okay, which is a cycle here. Now the join of these two graphs will leads to a wheel graph, okay, because at this point, okay, K1 contains only one vertex and no edges, right? That must be adjacent to every other vertices. So that is known as the join of these two graphs. And observe here, if we have a union of two graphs, then the number of vertices of G1 union G2 is nothing but the number of vertices in G1 plus the number of vertices in G2 minus the number of vertices in their intersection. And the number of edges in G1 union G2 is nothing but the number of edges of G1 plus the number of edges of G2 minus the number of edges of G1 intersection G2. And similarly, if it comes to the sum of two graphs, the number of vertices of G1 plus G2 is nothing but the number of vertices of G1 plus the number of vertices of G2. And the number of edges of G1 plus G2 is nothing but the number of edges of G1 plus the number of edges of G2. If it comes to join of two graphs, the number of vertices of G1 and G1 join G2, so that's nothing but the number of vertices of G1 plus the number of vertices of G2, and the number of edges of G1 join G2. So in such case, it is number of vertices of G1 plus number of vertices of G2 plus number of vertices of G1 into number of vertices of G2. Okay, fine. Here n stands for number of vertices, m stands for number of edges. Okay, so we can define product of two graphs or the Cartesian product of two graphs. See, so let G1 G2 be any two graphs, any two simple graphs, okay, The Cartesian product of G1 and G2 is denoted by G1 plus G2 is the simple graph with a vertex set V of G1 into V of G2, in which any two vertices u1 comma v1 and u2 comma v2 are adjacent if and only if, for the first case, either u1 equals to u2 and v1 is adjacent to v2, or the other case is v1 equals to v2 and u1 is adjacent to u2. So for example, so let me consider one example here. So let me consider G1. Okay, let me consider G2. Now let me calculate the product of these two graphs. Okay, so the vertex set is a comma b, and the vertex set of G2 is x comma y comma z. So the product of the Cartesian product of those two vertex set is what? A comma x, a comma y, a comma z, b comma x, b comma y, b comma z. Right? Now, how many vertices does the product of these two graphs have? That's my question. So for that, let me calculate the number of vertices of G1. So here the number of vertices is 2. And let me calculate the number of edges of G1, that is 1. And the number of vertices of G2, that is 3. Right? And the number of edges of G2, that is 2. Then the number of vertex is equal to 6. The number of vertices in G1, the product of G1 and G2 is 6. So you can multiply these two. Okay, so that will give the number of vertices in G1 into G2, and the number of edges of G1 into G2. So that is nothing but, so you have to consider 2 into 2, the cross multiplication, 2 into 2 plus 1 into 3, so that is 7. So that is the formula to calculate the number of vertices and edges of the product of two graphs. So this is the product of these two graphs. So I considered AB, the vertices AB, which is in G1, and consider X, Y, Z, which is in G2, right? So in the product of these two graphs, so first we need to write this. Okay, so first we need to write the vertices of G1 cross G2. So what are the vertices? A comma X, A comma Y, A comma Z, B comma X, B comma Y, B comma Z, right? Now, so look at the second coordinate here, X and X both are equal, right? Then A must be adjacent to B, right? And look here, A and A are equal, right? And X must be adjacent to Y. That's why we draw a line here, okay? And look here, A comma Y and B comma Y. So Y are same, right? So A must be adjacent to B. And B comma X and B comma Y. So B are same, right? So X must be adjacent to Y. So that is the rule here, okay? So if U1 equals to U2, then V1 must be adjacent to V2. Or if V1 equals to V2, then U1 must be adjacent to U2. So like that, we need to construct the product of these two graphs.